Hello everyone, good morning.
Good morning.
During this conference we have seen many different approaches to Islamic patterns. We have seen people that come from the mathematics world, physics, chemistry, design, art. Our approach is a technological one. We have a technological approach to this discipline, and everything we do actually integrates technology, modern technology. In our presentation you will probably not learn much about Islamic patterns, probably nothing, because we're not here to teach you. We are students, just like most of you are, and we have been learning about Islamic patterns from the experts that have given the lectures and workshops, just the same as you are now able to do. So I will show you a quick introduction that it will give you a first glimpse of what our approach is. So you can play the video. Well, it's a short video, 2 minutes, okay?
The advent of information technology has given our generation the tools to bring the ancient art form of Islamic patterns to a whole new level. Computational design has taken the mathematic and geometric burden off designers' shoulders, thereby allowing them to free their imagination from technical restrictions and exploit their creativity in unprecedented ways. The art form has therefore advanced in many directions. From the creation of huge non-periodic compositions to the use of intricate embellishment techniques. From the seamless articulation of the patterns with the rest of the design features in a building, to their implementation in modern architectural projects through integration with state-of-the-art building information modeling platforms and numeric control fabrication systems.
So there is a trend in most design disciplines nowadays that it has been showing us that many designers, architects, graphic designers, engineers also, many of them have realized that if they incorporate the ability to program computers, to actually write computer code, they can benefit from a set of new tools that the computational design offers. So what is exactly computational design? We all already know about CAD, right? CAD, computer-aided design. I'm going to show you another clip that will explain what exactly is computational design and how it differs from the tools that we already have been using already, and how the design tools have evolved during the last few centuries, let's say, because we will start from where Islamic patterns actually started, right? Había cargado el video que no.
Directions, modeling platforms, and numeric control.
Okay, sorry.
In ancient times, most pattern designers relied on very basic tools to develop the art form: a ruler and a compass. They created abundant catalogues of their compositions and used grids to produce both periodic and aperiodic tiles to cover surfaces larger than the composition itself. They drew every single line manually, mentally calculating the layout of interlace lines or other embellishments. The 20th century introduced digital imaging, vectorial design, and CAD software based upon coordinate systems. With these decidedly superior tools, many tasks were simplified. Designers could now draw precisely, save, and reuse patterns, use rotational or linear transformations, and could automatically produce copies, mirrors, and symmetries. With computational design, the rules of the art form are programmed into computer code. A designer with appropriate programming skills can produce designs programmatically. The task of designing Islamic patterns is highly suitable for computational design due to the fact that a composition can be described in pure mathematical terms. If the method of designing an Islamic pattern can successfully be described as a logical mathematical process, then a program can be written to replicate such a process.
So what is so great about computational design? Is there anything actually that is great? What does the new paradigm offer? Because we believe that it's a new paradigm, new design paradigm. You are not drawing lines by yourself, but you are instructing a computer to do it. What can we achieve with this? There are three in applying computational design to producing or designing Islamic patterns offers three very precise benefits, if you could call it like that. First, we believe it's much easier to produce really large non-periodic compositions. That has certain applications that we will explore later on. The second thing is that by using computational design, we can apply many different embellishment techniques to these large compositions, which normally is quite hard. If you have a very big non-periodic composition, that is, you're not repeating a tile, and you wish to draw interlaced lines, for instance, it's a very hard task, because you have to make sure that the rules of the interlace is respected all along a huge design, right? And the third element that we have been able to achieve is a new form of implementation and integration of the patterns with the rest of the architectural elements in a building. And I will play you another bit of the video that will explain these three things, okay?
Both when using traditional design methods and while using plain CAD software, there is a practical limitation to the size of the composition a designer can create. This is due to the fact that as a composition grows in size, it gets gradually harder to find the proper solutions within the rules of Islamic pattern design. Just as a modern chess engine allows the calculation of more moves than the human mind can handle, design algorithms allow the designer to create compositions which are way larger in size. There are very few large compositions in historic buildings that show intricate embellishment techniques such as interlace lines. The difficulty in drawing interlace lines lies in the fact that each line must travel alternately above and below each crossing line. The complexity of the calculations required to find an appropriate way to draw the lines grows significantly with larger compositions, to a point where it becomes impossible to do it mentally or by hand. Modern computer systems count with virtually unlimited memory, and design programs use that to their advantage, allowing the implementation of the most intricate embellishment techniques, regardless of the size of the composition. In traditional works, Islamic patterns are most often seen framed in a rectangle or in the shape of an arch. The ability to produce patterns through computer programs gives the designer full control of the design parameters, and a change in the program code can adjust the pattern to make it fit succinctly into defined spaces and articulate with other architectural elements. This offers designers new ways to implement patterns in architectural works, achieving a novel degree of integration.
Okay, so during this time, we have been working on a few architectural projects, and we soon learned that the AEC industry, that is the architecture, engineering, and construction industry, has very specific requirements for any sort of solution that a designer will offer or bring on the table. We have learned quite rapidly that the designer needs to have a holistic approach and a holistic vision. We need to see the big picture of how the industry works. Otherwise, we will find a lot of resistance from architects, from engineers, because it's one thing to produce a very beautiful concept, and it's a very different thing to actually be able to implement it and to execute it. If we come up with complex designs and hope that any contractor will be able to build it, we will soon be finding very steep walls that we will need to climb in order to convince the whole people that is involved in an architectural project that they can do it. What are these specific requirements of the industry? There are a few, actually. Scalability is one of them. The solution that you offer, the design you offer, and the solution to implement it needs to be scalable. That it needs to be applicable to small projects and to large projects. It also requires availability. That is, your solution must be universal. It has to be available in different places in the world. If an architectural firm is going to adopt a solution and incorporate it in the workflow, they need to be able, in order to properly monetize that solution, they need to be able to apply it in different projects, many times in different places in the world. And here we come also, the solution must be feasible in economic terms. If your design is going to put a lot of stress in the budget, if you're going to require a lot of money to build what you're proposing, you will most probably not see your design executed ever. We need to be conscious of what we are designing. We need to always design with the vision of how our design is going to be implemented and how we are not going to affect the budget too largely, right? We also need to be conscious about time requirements. If we are going to come up with a concept that will take an year to build, and we're talking only about ornamentation, we will probably get a lot of resistance from that also. And we also need to make sure that we are able to integrate with the workflow of all the stakeholders involved in the project. We can't just produce a beautiful design, a beautiful image, and tell them, okay, you take it and you develop it and you produce the working drawings and you build it. If it's something that they don't understand, if it's a complex pattern that they don't fully understand, we need to get involved in the whole process. And for that, we need to actually know the process, we need to understand it, and we need to be available to work with all the teams that work in this huge change that it's the design and build industry. So I'm going to show you one last bit of the video that explains how computational design helps us in all these matters to be able to offer new designs, new forms of implementations of Islamic patterns in mostly every sort of project. Okay?
The fact that the patterns are produced by computer programs means that the computer system knows everything about them and can fully describe the composition in mathematical terms. This allows programmers to create interface systems with leading building information modeling software widely used in the AEC industry, providing seamless integration with modern architectural and engineering design processes. The implementation of large non-periodic compositions could be much harder to administer than a small composition or a pattern repeated in a grid or tile. Most modern production, fabrication, and construction processes require certain repeatability to be feasible in economic terms. To the naked eye, a large non-periodic composition looks like a huge puzzle. However, the computer programs know the exact shape, dimension, rotation, and position of each polygonal piece that needs to be fabricated, along with the exact quantities and best assembly procedures. In other words, the program has got the solution to the puzzle. This allows the programming of the software to adapt, complement, or interface with existing fabrication processes and to administer the complexity of the assembly work by providing detailed building instructions, which too are generated programmatically. Modern fabrication processes are dominated by the world of CNC, or computer numeric control. CNC technology is based on a control paradigm where a computer manages the fabrication process by giving instructions to a set of robotic machinery. The commands given to the robot consist mainly of actions described by movements in the three-dimensional space. CNC shows obvious parallels with computational design, as one could see this design as a set of instructions to draw lines on a computer screen. This means that the logic programmed into computational design software to create Islamic patterns can be reused to generate a set of instructions for the robotic machinery that will fabricate the design pieces. These days, there are modern fabrication techniques capable of working with all kinds of materials, both natural and man-made. The ability to work with every modern production method translates into the ability to work with all sorts of materials available to the AEC industry.
Okay, so this was a quick overview of our approach to Islamic patterns, our approach on how to implement it in our modern times. I was going to say, if you have any questions, we can discuss the points that you are most interested in. Otherwise, I can just explain what we're doing now. But please, let's start.
My question.
Microphone, maybe.
Do I need to talk to you microphone? Yeah. To be translated. Thank you very much for a very nice movie. Great. Question is, as I understood correctly, then if we have, for example, a room with many, many different corners and different shape, then we should not be worried about like making the pattern that fit all the corners. So your system actually is the way that actually if we pick up pattern, you give it to computer, and then you give also the floor plan, and then it fits exactly the same as the size of the room. Am I right?
Exactly. It's not something that you cannot do with CAD software. I mean, computer-aided design also gives you quite a bit of control on ways on manipulating your patterns so that you can fit them to the spaces that you require, and in waves, and also in different sorts of surfaces. We don't necessarily need to talk about planar surfaces, right?
Yeah, that was my question.
So that is not absolutely new, but what computational design allows you is to have all this intelligence already programmed in your particular scripts that you will be able to use and reuse many times in many different forms, and then later adapt to use to very specific applications. So it's, if you take it to the CAD paradigm, it's like being able to program your own plugins for AutoCAD or for Rhino, Grasshopper, or whatever you're using as a tool, right? That is a part of computational design. You can either program on for a specific platform that already gives you a CAD environment, or you can build your own specific platform independent from any other commercially available platform. But it gives you, it allows you much more control on how to modify and transform your patterns, both to adapt them to a specific plan form or to a different sort of surface, talking about domes, talking about cylindrical surfaces, columns, irregular surfaces even. Comes to my mind the work that Jean-Marc showed us yesterday, this huge sphere, or the balconies that he showed in Abu Dhabi. They are all surfaces that are not planar, and that we can plot into those surfaces. If you can describe them mathematically, the constructions we were doing yesterday, then you can program scripts that will help you to implement those patterns in this quite different context to what we have in the traditional implementations.
Thank you very much for this beautiful lecture. I have two questions. The first one, we saw the first part of your film, and there's some buildings, beautiful buildings. Have you built those buildings with something you just presented?
Okay, everything you have seen in this presentation are concepts that we produce for ourselves. The concepts that we have produced for actual projects, we cannot show them yet. We're still under non-disclosure agreements because they haven't been built yet. So we hope that one of these days something will come up and we will be able to show. But so far, these concepts are just free creativity from our side.
And my second question is a bit harsh, but having been brought up in this environment of the plastering, I could tell the difference between the machine-made plaster and handmade plaster, and I could see you know, the reaction to the man-made and the machine-made concept. Do you have any feedback on this? Because it's just, I found the machine-made a bit harsh because it's something made for a large consumption, whereas the handmade plastering, for instance, it's very elaborate and very expensive. Is that dying for, you know, giving room to CAD production?
Okay, here we come to a subject that is very important, and I have got feedback, yes, and one thing that we probably need to clarify is that in our vision, we are not here to replace craftsmanship. We are not here to replace the way the art form has evolved and the way craftsmen are dealing with the art form. We believe this is a completely different market, if you wish to see it in commercial terms, and it's a completely different art form also. The same way as we don't do web design by drawing papers and taking pictures of them and putting on the internet, we believe this is just a new paradigm. One thing that may have caused some confusion is that we used, for the machined samples that you saw, we used sort of traditional designs that look very much and are actually copies of traditional designs. That doesn't need to be like that. We indeed need to work on different forms of design that are specifically made for the production in this sort of technology. The reason why you saw these designs, and of course that you will see many differences between what craftsmen do, is because it was just a test. It was my first test. The last piece that you saw carved in plaster, it was my first test when I was learning how to use CNC machines, when I was learning how to program those machines, and I wanted to see what was possible to do with that, and actually to do exactly that comparison of what is being done in the world of craftsmanship. We don't intend to even look like a handcrafted piece. We need to, as you saw in the rest of the concepts, we are not here to produce maybe Selish, you know. That's a different thing. It's a different art. It's an art on itself, of course. We are here to offer new ideas and new forms of implementation. So if we do get to produce plaster carved pieces, it will be the design will come from a different side, with a different approach.
Okay, thank you.
Can I have this? We are just approaching the same issue over and over again. That's a history. That's a really history. You see, Istanbul was facing economical problems far in the past because at some stage there was this industry booming in the West, and they brought machines to Istanbul, and most of the craftsmen collapsed, simply collapsed. And you see, this is happening over and over again. Here we are going the same way. Traditional handcraft design is going to be replaced by something that is done by machinery. I really admire this work. For years I was doing things with the computer, but whatever I do with the computer is lacking human touch. And here also you have very cold design. As this looks like glass and iron, cold without a human touch. Sorry, this will be happening again and again. We cannot stop it, but we have to think still about this. In order to develop the next generations and next generations and next generations, we still need a human touch. We have to train brains. Maybe we have to train them the new way, like these guys are doing, but I still believe that we still need the traditional geometry and traditional knowledge that we learned in the past in the school. So there are two ways, and we have to find a balance between them. Craftsman is important, human touch is very important. We cannot replace it totally by the computer production.
Well, this is just a comment. I'm kind of like moderating between the two extreme views. It's the same recurrent discussion. Even since the Industrial Revolution, there was the fear that new machines will replace handcrafts. The story of the sewing machine singer, for instance. You know, all tailors thought that this new machine will replace them, but probably the craft lies somewhere else, not exactly in that physical action. Maybe it's maybe in the intellectual creativity of.
I agree. Yeah.
There is a comment that of the German master of the Bauhaus school, Walter Gropius. He said, "A machine is nothing but a refined hand tool." Thank you.
Thank you. In our view, or I will make just a comment. In our view, well, like I said, I don't believe that technology will absolutely replace craftsmanship. How many of you can, at this point in time, afford to have a beautiful Salish wall at your homes? Or how many of you can afford to have your home decorated as a Moroccan riad, for instance? It's really, the truth is, this is not available for all of us. And if we do get to industrialize the production of some products, then we will just be able to have them available in the US, in Europe, in Latin America, and be able to enjoy the art form. And we don't need to be princes to do that, or royal family. You know, that's our approach. We believe that mosques, we believe that palaces, we believe that institutional buildings will continue to be developed in the traditional way, because there is a lot of sense in doing it that way. And what we intend to do, and what we will show you after your questions, is exactly that part of the business that we are developing now, because we are developing a serial production for one specific product that you will eventually be able to consider to buy or to have in your home.
Actually, the last comment, because now the next speaker is waiting. Actually, the same example actually may apply to other things. Like in Iran, we have an instrument to play which is very popular. Its name is tar. Tar is a music instrument that is very, very traditional. And then the big masters of tar try to keep that instrument exactly the same as past. Actually, they don't let the bridge change or anything. What is the result? The result is the new people in Iran, young people, go and play guitar. Is it good? To insist too much that to keep the traditional, that they, take away all the young people to West? Is this not? Is not good. Let people have talent and use this talent technologically to impose to patterns and slowly show the young generations who study in engineering and full of ideas appreciate the old design, rather keep there and emphasize too much there in a way that everybody goes to the West who is ready to accept all the modern ideas. So somehow we should be a little bit careful about our approaches. And actually the next speaker, I think, is waiting for us. And I give it to you. Don't any more comments. He feels that he always wants to share with you.
Thank you for this discussion. We could talk about this for hours. The next speaker, Jay Bonner, This in line.
Okay. Thank you.